What? Who? What? Where? Huh? Here we go. Welcome back. Guys, it's Monday. Who's excited? Who's excited? Who's excited? Because I'm not. But look at me faking it. Look at this face. This is a face that pretends to be excited. Do you see it? I could be like this. I mean, this is where I want to be. Oh my gosh, guys, we're going to do geometry. Are we ready?
I could just like not do geometry today.
I could just not do geometry. That would, oh my gosh.
That would be amazing.
That would be such a great idea. I want administration, since you guys watch these. That's Lucy. Lucy as in L-U-C-Y, telling me not to do my job. Just letting you know.
Me and Pfeiffer are pretty tight, so.
Mr. Pfeiffer, because it wasn't even Mr. Pfeiffer. She wasn't even putting respect on your name. It was just Pfeiffer. Oh my gosh, I can't even imagine. We're not even tight. I can't imagine how she talks about me. I'm gonna ask your mom. Okay, ladies and gentlemen, boys and girls, children of all ages. So, solving equations, you need to know how to solve equations. Plain and simple. Balance point. Then what? Which side, Ella? Left or right? No, I don't care. Your choice.
I did left.
Okay, so what am I doing?
You,
Yes. Correct? Distribute.
Yeah.
I take the 3 and I multiply it to the x, and I multiply it to the -9. Now listen, I am just teaching this to my algebra kiddos now. When I distribute and when I show it, I physically show what I'm multiplying it to and put the multiplication symbol there. And I tell them, hey y'all, listen, 3 times x is 3 times 1x, which is 3x. 3 times -9 is -27. But that's not all. Oh, I just sounded like an infomercial. But that's not all! What else do we have to do? Ella, it's still on you.
Do we distribute the other parentheses?
We do. What are we distributing?
The invisible -1.
Ah, the invisible -1. Very good. Why are you guys laughing? Why are you laughing at me? Did I say somebody's name wrong? Because I don't know to do that. Am I saying your name wrong?
No.
Then why are you laughing at me, Esther? Stop giving me a complex. -1 times 4x. -1 times +8 is -4x minus 8. Now, today, what I'm truly doing in algebra, like this is what, so I taught distributing on Friday or on Thursday to algebra. Today we're talking about combining like terms. And let's see if I can find it. This is good. Here we go. Okie dokie, you ready? I have got a cup and 2 markers. How many markers do I have?
2.
Ooh, well, look at you, fancy pants. Oh, now look, wait. Lucy, how many markers do I have?
2.
But there's a cup in the middle, Lucy. How many markers do I have?
I'm gonna be so stupid.
How many markers do I have?
Also 2.
Even though there's a cup in the middle?
Yeah.
Oh, so it doesn't matter if there's a cup in the middle, right? Because we've named them markers. So if I look up here, I have 3 xylophones. Do I have other xylophones? Because that's what X starts with. I don't know any other X words. X-rays. Do I have any other X-ray machines? Yes. Where are they? What other X-ray machines do I have? I need you guys to come on.
There's a -4x.
Yeah, the -4x. Those are like terms. 3x minus 4x is just 3 minus 4, which is -1x. Yeah, but Mr. H, you've got those numbers. Yes, I do. What do we call those numbers that don't have a variable? Starts with C and ends with an constant. Go ahead, Esther.
Constants?
Constants are always like terms. Now notice what I did. I circled my like terms and I boxed in my other like terms. -27 minus 8 should be -35 equals, because this is done. Can't do anything else on the left. So let's do the right. Lucy, what can I do on this right-hand side?
Combine the 7 and the 9.
Yeah, what kind of 7? What kind of 9? And? Oh, so -x drops. 7 minus 9 is -2. Okay. Ooh. So now I'm adding 1x to both sides. -35 equals negative 2. Wait a minute. 1x plus x is 0. That's gone. 1x plus, oh. So I have an equation that says negative 35 equals negative 2. Is that possible?
No.
Does negative 35 ever equal negative 2?
No.
No. So the answer to this equation is no solution. You can have equations where you cannot get a solution because it will not work. No matter what we substitute in for x, we cannot balance both sides. That is called no solution. Okay? Both of y'all who are still working on your test, you're going to want to watch the video and copy this down. Are you done?
Yeah.
Oh, then you can go back to your seat if you'd like, or you can stay there. It doesn't really matter. Okay. You're done too? Hot dog, hot diggity dog.
We trying to Mickey Mouse now?
Yes, sir. What?
Trying to Mickey Mouse now?
What? No, what?
We trying to Mickey Mouse now? Is the song from Mickey Mouse?
Yes, thank you. I do know where it's from. You are correct. Okay, so questions on this? May I erase?
Yeah.
Yeah.
Cool. We are in chapter 2. We are talking about inductive reasoning.
For what? I don't know why that did not sound like a word.
Inductive reasoning. Making a conjecture, which is a guess, based on several examples. Were you able to see that? You see this? Yeah. I think there's a glare. I'm going to roll this down. That might make it a little easier. Okay. So that guess is called a conjecture. That's our conclusion. A counterexample. Okay? And it's not even one of the definitions in here. Like, it talks about counterexamples, but it doesn't have a definition in here. A counterexample, an example that proves the conjecture false.
So it's like debating.
Yeah, it's like debating. You're finding something that proves that it does not work. Okay, so watch how we're going to do this. Here's our example. One by 2 is 2. 1 by 4 is 4. 1 by 6 is 6. My conjecture, based off of these, anything multiplied by 1 is even. That's my conjecture. Based off of the examples that I'm seeing, anything multiplied by 1 is even.
Okay, but what do you do?
Wait, shh, Esther, wait, wait. Sorry. So a question like this would then say, either prove it or disprove it with a counterexample. So a counterexample is proving it false. Right now I'm saying 1 times anything is even. 2, 4, 6, 10, 12. Give me something that's not going to be even. Go ahead.
1 times 3.
So the example, 1 times 3 is 3. There's a counterexample.
1 times 1.
Okay. Are they always going to be that easy? No, but there it is. Now, what else do we do about inductive reasoning? Inductive reasoning is what, and I know that this is not a knock on you because this is high school geometry. Inductive reasoning is what my children do. Truly and honestly, it's what my children do. Because Cole and I will play this game all the time. Find the next figure. I love trying to do this with my kid. So based off of what's there, Cooper, you can come back up a little bit. You don't have to be back there. Like we're almost done. Like truly, we're almost done. What are we seeing? Somebody look at this and explain what we're seeing besides Esther.
No.
Go ahead, Cooper.
It's adding a side.
Okay, so this is 3 sides, 4 sides, 5 sides, which means this one should be 6 sides. So it should be, yes, nice.
That's a pretty good hexagon.
Find the next 2 numbers. Okay, a little bit trickier. You'll need a calculator. So what's happening here? There might not be enough information. I think there's enough information.
I'm just like trying to.
So, what do you think? Who has them? Ella, what do you think? You don't know? Okay, Esther, what do you have?
I have 256.
So this is 256?
Or no, 1 over 256.
Oh, okay. And?
And 1 over 65,536.
65,000 what?
536.
Okay, so here's what Esther did. Esther said 2 squared is 4, 4 squared is 16, 16 squared is 256, 256 squared is 65,336. That's all good. But there could be others.
Does that say find the next 2
Numbers.
numbers? Okay, I understand.
But what if I said, hey, I'm doing 2 times 2 is 4, 4 times 4 is 16, 16 times 8. What if I want to multiply by 2, by 4, by 8, by 16? So 16 times is 1 over 128.
And then, yeah, find that.
And that gives me 1 over 2,048. This is what's the problem with inductive reasoning. There might be a pattern, but I might have just said this is 1/2 and this is 1/4. Maybe it's just repeating these 3. You don't know that. You can only base it by what you see. So there are going to be questions that I'm going to give you that are going to ask you to find two numbers, two different ways to find them. So maybe it's this, maybe it's this. Inductive reasoning is really based off the pattern. A counterexample is just proving that it's false. This is not elementary math. It's certainly not, because it's going to require you to think a little bit. But there is not much to it. It's finding patterns. Like if I said 1, 2, 3, 4, 1, 2, 3, 4, what's my next two numbers? 1, 2. But maybe the next ones are 12 and 15. Just because there's a pattern, it doesn't mean that it's going to follow. It might be 1, 2, 3, 4, 1, 2, 3, 4, 12, 15, 12, 15, 1, 2, 3, 4, 1, 2, 3, 4, 12, 15, 12, 15. Okay? Inductive reasoning is based off of what we see. Questions? So, this is not homework. This is what we are working on right now to prove that you know this. You are going to do 1 through 6. Actually, let's go 1 through 14. I want you to do right now 1 through 14. Okay? Go ahead. 1 through 14.